Check it out, I've made a level crossing signal for a model railway. So it's time for another lolly tin pedal build. I've got 5 of these old lolly tins that I found and I'm turning them all into pedals. So far I've done a distortion pedal and a chorus pedal. These two are kind of modded and rehoused commercial effects, but with this build I'm actually going to create the circuit myself. I've already done some prep on the tin itself, just like the others. I've cut a little piece of scrap timber, I've glued and screwed that to a metal disc, and then I've glued that in turn to the underside of the lid to reinforce the whole thing so it'll take a stomp switch and take, well, being stomped on. I've been looking through all of my tremolo circuits, specifically the ones that use Vactrols, and there's one circuit that has caught my eye. It's this guy. It's from the ESP website. ESP stands for Elliott Sound Products. Rod Elliott has served the DIY audio electronics community for well over 20 years. In fact, I think this circuit dates from 1999. I'll try and find the original project page and I'll post a link in the description, so check it out. The website's really, really remarkable. There's like hundreds of projects and designs and articles. It is a really amazing body of work, so definitely check it out. The thing that caught my eye about this particular tremolo circuit is the placement of the Vactrol itself. So this guy in the middle is our Vactrol. This is listed as a VTL5C1, which really is a Vactrol. There were other parts that were quite similar, NSL32s, CLM6000s and a few others. These are what's known as an opto isolator or a resistive optocoupler, and they were really common not just in tremolo pedals but classic phasers, compressors, and also things like Mutron VCFs, voltage control filters. By the 90s, most of those parts I mentioned were obsolete, and if you got into the hobby of pedal building and stuff back then, or in the sort of first decade of the 2000s, it's most likely you would have just had to make your own. There was some new old stock floating around on the market, but mostly we made our own, and that's actually what I'm going to do for this project because they're super simple to make. Some of these parts, Vactrols for example, are back on the market. You see them on eBay and some specialist electronic suppliers. I've also seen NSL32s on the Pedal Parts Australia website, so you can buy them, but yeah, they're super easy to make. What you have here is an LED, and then this guy here is an LDR, which is a light dependent resistor, and then it's just encapsulated in a light tight package of some sort. When the LED is switched off, the LDR is sitting there in pitch black and has very low conductance. In fact, it's very nearly an open circuit. And then when the LED switches on, the LDR starts to conduct, and I think I measured about 200 ohms with mine. The thing that caught my eye about this particular circuit, as I mentioned, is the placement of the LDR. All of the other tremolo circuits that use opto-isolators that I have the LDR in line with the signal, and that works great, but as you can see in this circuit, it forms the bottom half of a voltage divider attenuator. So what that means is that, well, we know that a tremolo pedal, if this is our kind of loudness, I guess, then the output of a tremolo pedal literally just goes loud, soft, loud, soft, loud, soft, loud, soft. Well, with those other pedals, with the part of the cycle, say, where it goes from soft to loud, that occurs when the LED switches on and the conductance rises in the LDR. Whereas with this circuit, the soft to loud part of this cycle occurs when the LED switches off. And look, you might think that really makes no difference, but the thing about an LDR is that the way it switches on and switches off, well, it doesn't do it at the same rate. In fact, its conductance rises very rapidly, but it falls much, much more slowly. So what that means is that in those other pedals, you tend to get a fast rise of loudness and then a slow fall. back to, you know, soft. Whereas with this pedal, this is becoming a mess. With this pedal, I think we'll get a much slower rise to loud in the soft to loud part of the cycle, and then a more abrupt fall, etc. And well, I'm curious to see if you can actually hear a difference in these two approaches, and if so, well, I'm interested to see if it gives us a kind of a different flavour of tremolo, where the leading edge of each audio pulse has a softer, more burnished attack, I guess. Now, this circuit as is actually designed to work as part of a preamp build or something like that, so it's got a bipolar power supply, which also means it doesn't have coupling caps, and its input impedance is fairly modest. So with my design, I've made it work as a pedal. So it works on 9 volts. I've got a rail splitter here, which is I've used an op amp for that, just because of the current demands of the oscillator. And obviously it needs coupling caps now because it's biased to 4.5 volts. I've also changed the input buffer, and that's because, well, I just don't have any single op amps on me, and I'm really just using up parts I already have, much less a rail splitter IC. So an op amp with infinite feedback will work fine for that. I've reworked the oscillator as well to work on 100k pots, again, because I just happen to have some left over from another project. And I've also tweaked its sweep, so its rate goes from 1 Hz up to about 10 Hz, which is roughly the same as the Boss TR2. I think it's a nice sweep for a tremolo pedal. The other thing I like about the Boss TR2, and here's the schematic, is this guy, the wave control. It's that third pot, and it allows you not just to switch from triangle to square wave, you can actually sweep from one to the other. And the way they do it here is just by putting a gain pot in this op amp that follows the oscillator, and I've done exactly the same thing here, and I'll explain that in a bit more detail when I show you the breadboarded oscillator, when I hook that up to my scope. One of the issues with this original design is that with a 100k pot and a 100k input impedance of this output stage, then that means with the depth control cranked, it means that the output peaks are still going to be like 6 dB quieter than the input level. So to minimize that, I've increased the input impedance of the output stage, and I've also reduced the depth pot. I don't actually have any C50k pots, but luckily these ones are actually dual gang. So if I just wire the two gangs in parallel, they'll work as a 50k C taper pot. Little hack there for you. The other thing I've done is add a gain control to the output stage. And that's partly to overcome what remains of a slight drop here, and also you do lose a small amount of gain through this type of input buffer, maybe 1 dB. But it's also because with tremolo pedals especially, even if these peaks are at exactly the same level as your input, well, you're still losing all of this volume in here, and it just seems to, it sort of feels like you're losing volume when you kick it in. So having a gain control here means you can overcome that. You can even boost it. This has got 15 dB, or a bit over 15 dB of gain here, so you can even boost it to the point where you're breaking up an amp or something. The other thing I've just done when I've been fiddling with my breadboarded oscillator, I've actually just put a 4148 diode in line with the LED that's inside the Vactrol, and I'll explain why that is in just a sec. So I've breadboarded the oscillator, and I've connected a couple of LEDs straight to its output. So you can see that they turn on and off alternately, and I can change the speed here, speed it all the way up or slow it right down. And this is the gain control, or the wave control of the gain in that second op amp. And again, you can see that they're sort of throbbing on and off alternately, but if I crank this up, they start turning on and off much more abruptly. Check it out, I've made a level crossing signal for a model railway. So now I guess I'll just turn that back down to triangle wave and I'll disconnect the LEDs. And if we look at the scope, we're looking pretty much at a straight ahead triangle wave. There is a slight difference in the upward and downward slopes, and I think that has to do with this electrolytic cap and the fact that it's possibly charging and discharging at a slightly different rate. But if I crank that wave control, you can see that the tips of the wave start getting clipped, and I crank it more and more and they get clipped more and more to the point where I crank it all the way up, and there you go. It's kind of approaching a square wave, and like I say, that's exactly how the wave control in the TR2 works. So if you've ever messed around with any drive pedals, this may look familiar, because two diodes like this wired in parallel but opposing in polarity, well, they're just clipping diodes, and the signal here will be limited to their forward voltage. So if I plug that back in and get the LEDs going again, you can see that the waveform has dropped down to twice the forward voltage of the LEDs themselves. So it's about 4 volts thereabouts. Okay, I've removed one of the LEDs and I've replaced it with the LED half of one of my homemade Vactrols, and I've also set up a little bit of current running through the LDR side of the Vactrol, and if I hook that up to the second channel of this old USB scope, we can actually see that switching on and off. And you can also see how much more slowly that conductance falls compared to how quickly it rises. So now if I turn up the control, that wave control, you'll see the wave get more and more clipped, and you'll see these sort of silent gaps get further and further apart. And if I crank it all the way up, again, our waveform is very nearly a square wave, and this will give us quite a choppy sort of sound. I think it'll be pretty cool. So as I mentioned, since breadboarding the oscillator, I've added a diode, a 4148 basic silicon diode, in line with the LED that's in the Vactrol, and that has to do with adding more scope to the control, but back in the anti-clockwise direction. So just before I had that diode shorted, but if I remove this jumper, it's now in line with the LED, and what that does, it raises the overall forward voltage of the two diodes by about 0.6 of a volt, which is the forward voltage of this diode. And you can see that now the top end of this wave is not clipped as much, and what that gives us with the wave control turned all the way down is less off time. And so yeah, it just gives the wave control more scope. So if I turn the wave control halfway, we now have roughly even on and off times of the Vactrol, which will give us roughly even loud and soft times of the tremolo. Or you can turn that down and get much more on time than off time, or you can crank it up and get much more off time than on time. Now, before I disconnect the scope, there is just one other thing I wanted to show you. This homemade Vactrol, well, I've actually made it with red heat shrink because it's the only coloured heat shrink I have that's the right size, and even with an extra layer of masking tape for my little label there, it's not completely light tight. And if I just put my hand over it and cut out the light, then you can see that the waveform, it is higher here, and that means it's actually switching off to a higher resistance. Now, I'm not really sure what's in the original Vactrols. I assume they're just basic red low output LEDs. For this project though, I've been messing around with these nice bright sort of modern water clear red LEDs. These are rated at 3800 MCD and their forward voltage is 2.1 volts. The LDRs, light dependent resistors, I just picked these up at a local electronics shop, and these are rated at 5 k ohms light resistance and 500 k ohms plus for dark resistance. Bit misleading though. With these bright LED lights that I use for shooting, this is about 1 k ohm, and if I block out the light altogether, with some blue tack. Well, my meter's already into megohms and it's going to run out of puff. So now it's more than 100 megohms. That's as high as my meter can actually measure. So it's almost an open circuit, to be honest. To make your own Vactrols, it's pretty simple. It's really just a matter of gluing the two parts together. If you can get the blue tack off them. What I normally do is actually start with some blue tack like that, and I'll make a bit of a groove in there. Then on the LED, I just use like a plastic primer pen, and I'll just paint a bit of that on the top. This sort of plastic super glue doesn't really stick to it very well, so you need a primer. And then I'm just going to lay that down like that, and the blue tack's good because I can get the LDR lined up well. That looks about right. Now I've got a bit of medium CA glue in a lid and a toothpick, and I am just going to put 2 or 3 drops on and let that run down into the joint. And really, it's just a matter of waiting till that sets up. I didn't use accelerator, and that's because that will often make the glue boil and it will be kind of hazy looking, and I think that would block the light, so I just let it dry naturally. So that glue's all set up, so I'm going to put this into some heat shrink. Ideally I'd use black heat shrink, but I don't have any black that's this size. And while the ends are still warm, I like to pinch them shut with some pliers. And there it is. So I did end up painting this with a couple of coats of satin black because I think it will help with testing the circuit. And with the multimeter hooked up, well, it's maxed out again, so it's over 100 meg in resistance, and if I hook the battery up to the LED, it very quickly drops to about 400 ohms. Alright, it's another day in the mod cave and I've done some stuff. I ended up breadboarding the rest of the circuit, and that's so I could do just a couple of little tweaks on the audio part. I ended up reducing the coupling caps through that audio part of the circuit, and that's because it sounded, well, a little bit thumpy in certain settings. So by reducing the coupling caps, I was able to raise the roll-off up to, I think it's 15 Hertz or maybe 18 Hertz, I think it was. The other thing I've done is I've increased the wave control. That gives that op-amp that follows the oscillator a little more gain, and it gives the controller a little more scope, but it still retains a nice even sounding sweep of adjustments. Once I was happy with the circuit itself, I sat down and created a quick little strip board layout. The top tip here, well, I don't know if it's a top tip, but it's something I like to do, is to print the top side on one sheet and then the rear side on the other sheet, and then make sure they're orientated correctly and then staple them together. That way you can sort of flip this over and move it around, and you're less likely to mess up your circuit when you're populating the board. The board itself is 33 millimeters wide, and that means, just like in the other projects, I'll be able to mount that on this piece of timber. It's also only 55 millimeters long, so if you did want to try this project yourself, but with a standard type of pedal enclosure, it should be pretty easy to achieve. Next thing I did was drill out my lolly tin. The trick there, well, the thing I found drilling this really thin tin is not to actually use regular twist drills, because they just punch through and give you a really ragged looking hole. The trick there is to actually use brad point bits. Well, they're normally designed for timber, but in this case, once the little point punches its way through, you just back off the drill and then just sort of rock it side to side, and that way the outer spikes just sort of score their way through and you end up punching out a really nice clean hole. So once the lid was drilled, I could scan that and then create some labeling for it. I'm just using water transfer decal sheets like I've done on loads of other builds. For the top though, I've actually done ones for white transfer paper. which I think would look a little bit silly on these other lolly tins, but since this one has a black and white design, I don't think they look out of place. Once they were applied and dried, I've given that one coat of semi-gloss clear so far, and I've also painted up a set of knobs. I found 4 matching black knobs, but they look a little bit drab, so I've painted 2 of them white, and that'll sort of follow that black and white theme through for that one. The other thing I did was paint this piece of timber with I think 2 coats of just a clear water-based sealer that I just happen to have kicking around. You could use just about any type of paint for this, but you especially want to seal up the end grain of timber. I did it with the other builds, but I think I forgot to mention it in the other videos, and that's just to make sure the timber stays nice and stable. It doesn't warp or crack or anything over time. So now it's just a matter of getting on, giving the enclosure another coat of clear, and populating my little circuit board, and then wiring it up and see if it all works. Well, that didn't quite go to plan. I loaded up the board, wired up the pots, and then I created a little test rig. And when I plugged the guitar in, well, everything worked okay. All the pots did what they're supposed to, but there was a ticking sound in the background. It's kind of disappointing because the circuit worked just fine on the breadboard. But to be honest, these sort of issues with low frequency oscillators are not uncommon, not just with tremolos, but when you're tinkering with chorus circuits and flanger circuits, phasers, synth modules and stuff. It does happen. I did try a few quick fixes on my little board, and they all helped, but the ticking sound was still very quietly there in the background, so I knew I'd have to dig just a little bit deeper. So the first thing I did was take another look at the Boss TR2 circuit. So down here is the oscillator for the TR2, the low frequency oscillator, and this guy down here is the bias voltage for the oscillator. And even though it's 4.5 volts, just like the rest of the pedal, Boss have actually created that bias voltage with a separate set of components, a separate voltage divider just here. So down here is the one for the rest of the pedal, and here is the voltage divider just for the LFO. So obviously Boss knew that it was important to separate or kind of isolate those 2 reference voltages. So I've done the same. Here's my version 2 of the Lollytin Tremolo project, and down here you can see I've got a separate what I call reference voltage B, which services the oscillator, and VREF A is for the audio part of the circuit. But I've actually taken that a step further and also created an isolated 9-volt rail, complete with its own decoupling cap. Obviously with those extra components, I had to redesign the strip board layout, and so here's my new strip board layout. It is a little bit longer than the other one, but I think it'll still fit in here easily enough, and I think it's still small enough to use if you want to try this project yourself in a standard pedal enclosure. When I redesigned this, I was a little more conscious of that interference from the LFO into the audio path, so this board features more separation of the 2 parts of the circuit. So the bottom half is the LFO and the top half is the audio circuit, and you can see the A rails up here and the B rails down here. And right in the middle is where they sort of technically join with the LED LDR. So here's the circuit built up, and yeah, as you can see, it's just a touch. It's about 1 centimeter longer than the other. Separating the 2 halves of the circuit also allows me to run the wires to the LFO pots separate from the other wires as well, and that's especially important for this guy here, which is our rate control, and that's because it's connected directly to the output of that first op amp, which has our rail-to-rail square wave, or nearly rail-to-rail. The third thing I've done is, as you can see, I've used a shielded wiring on the input, and that's because the input is at a high impedance. The audio signal there is at high impedance, and it's quite susceptible to interference. So that obviously comes from the stomp switch, and I'll use the same wire from the input jack to the stomp switch as well. And for convenience sake, this spare track up here, or trace, I've actually connected that to earth. It just makes it more convenient. It only needs to be connected at one end, of course, and you can see that's exactly what I've done. I've connected the shielding at the circuit board end. So with those 3 tweaks to the design and the new layout, I've just wired this up and tested it, and yeah, it works perfectly. So I'm happy with that, and I can get on and do the final wire up and get this pedal finished. Yeah, well, that seems to work pretty well. Pretty happy with that. I really like the way it looks as well. I love these patinated old lolly tins. I think they look really cool as pedals. So over the next couple of days, I'll put a PDF up on my website with the schematic and the strip board layout and everything. So check it out if you want to give it a go. It's not what I'd call a fully fleshed design that's kind of ready for a commercial effect pedal or anything. It's definitely a project for people who are willing to experiment and tinker a little bit. The LDRs I bought, I think I bought 5 or 6, all the same part number from the same supplier, but they really did have quite variable electrical characteristics. But I think it sounds really nice, so I'm happy with it so far. So I hope you enjoyed the video. If you did, please like and subscribe. Thanks for watching. I'll see you in the next one.